Hello students, today we are going to see another name reaction, that is electrophilic substitution reaction. Now what is electrophilic substitution reaction? What is electrophile? First of all, electrophile are those who is in need of an electron. So they will be in search of an electron, so they will substitute at that place where the electrons are rich. Okay, the first thing. Second thing, substitution. So the reactant, in the reactant they will be substituting, so they will be removing the hydrogen or something like that. So there they will be coming and substituting them. They are going to come and attack them, in short. Okay, so that is called electrophilic substitution reaction. Now if we are talking about here, majorly it happens in aromatic compounds. So I have taken here chlorobenzene here. So before we further go with an electrophilic substitution reaction, let's understand few things. The product that we obtain here is always, the major product that we obtain here is a para product. Okay, para position product will be the major one, whereas the ortho position will be the minor one. Okay, why? The reason is because the more crowding will be there, overcrowding will be there, so hence repulsion will be there. Hence we consider the ortho position to be the minor one and the para position to be the major one, as there is a repulsion is less, as they are very far from each other. Now if we are talking about this one, in the case of chlorobenzene, 1 and 4th position is actually a para position. How I consider this? I consider on the basis of the chloro group which is attached to the benzene ring. Okay, so 1 and 4th position that you can see here, which I have highlighted, is actually a para. 2 and 6 is a ortho, and 3 and 5 is a meta position. Okay, so if the group is attacking or electrophile is attacking at 2 and 6 position, we say ortho product we have obtained, and if it is attacking at 4th position, we say the para position the group has attached. Okay, so let's see what are the different types of electrophilic substitution reaction do we have. So we have basically these are the common one: halogenation, nitration, sulphonation, Friedel alkylation, Friedel acylation. Now I am segregated into a table so that it is easy to remember the reagent and the electrophile which is going to attack, and let's see what are the products that we obtain. So if we are talking about halogenation, so in halogenation, obviously halogenation means either the chloro or the bromo group. Okay, so chloro or the bromo, so Cl2 or Br2 in the presence of anhydrous FeCl2. So what is an electrophile here? Either Cl or Br. So the product that we obtain here is, you can see here, this was our reactant. This whole thing was our reactant. So as I told, it attack at para position, so I am showing here the electrophile, the Cl is going to attack here. Suppose it is bromo, so I just have to replace here Cl with what? A Br. That's all. Okay, so this will be the product that I will be obtaining. Now nitration, from the word itself, nitration means we are using a nitric acid. Okay, that you can remember. And so the electrophile will be what? NO2. So in order to get an electrophile NO2, we have to use a reagent, that is concentrate HNO3 and concentrate H2SO4, that is sulfuric acid. So the product that we obtain is a so the nitro group is NO2 is attached at what position? Para position again. Sulphonation. Sulphonation word itself say that means concentrated H2SO4, that is sulfuric acid alone we are using it, and the electrophile that we obtain is SO3H. What we obtain? SO3H will be the electrophile. So SO3, that is sulfonic acid, we say sulfonic acid. SO3H is going to attack at the para position. Okay, so I am just showing here the para position. So at ortho position also the same electrophile SO3, but the product that we obtain at ortho position, as I said earlier, will be the minor one. Okay, now Friedel Alkylation itself means CH3 group. Okay, CH3 group, that will be acting like an electrophile. So CH3 group is going to come and attack. So in the presence of anhydrous AlC, what is anhydrous AlC here? It is a Lewis acid which is acting like a catalyst. Okay, that means they will not act helping to speed up the reaction. Okay, so here, so what will be attacking at the para position? CH3 group will be attacking. Friedel acylation. So here the acyl halide is used. So you have to be very careful here. What should be careful? The group with the electrophile that you're using is COCH3. Okay, that means the bond between this C double bond O and Cl breaks. Okay, and this CO, that means a carbonyl group's carbon, okay, is going to attack at the para position or the ortho position. So you will be getting here like this, CO, you can see here CO, C double bond O, C. So not CH3 carbon is going to attack at the the para position. You have to be very careful. Students usually make a minor mistake there. Okay, so you have to be very careful. So generally we call this this thing as what? Acetophenone. Generally we call this as an acetophenone. Hope it's clear. If you remember this reagent and if you remember the electrophile, okay, how, what is this thing, you are able to write the product easily. Now if you have understood this, kindly do this question and let me know if you are able to solve it or not in the comment box. So here that I'm using here, the reactant that I'm using is an anisole. So only thing you have to keep it here, you have to write the reagent and the final product. Okay, so let me know whether you are able to solve it or not. Thank you.